Hey everybody, welcome to a bonus screencast for the first week of Advanced Programming with Java at Portland State. It's here, actually it's the 4th of July, it's my day off. I got a couple of hours between like the parade in the morning and the fireworks in the evening, and there's something that I wanted to do a screencast on to tell you about. It's called continuous integration. And it's kind of a nice bridge between what we saw last week with Maven, with building Java projects, and some of the stuff we'll be doing next week, where we're really focusing in on test-driven development and having automated tests. And I'm kind of doing this one by ear. Oh, and I'm outside. You can probably hear birds and cars and stuff in the background. It's a very nice day. Want to get a little bit of sunshine and fresh air while I'm doing this. I'll dive right in. Continuous integration. So we saw last week that with Java and with Maven, you can have an automated build, meaning that you can use Maven to say, hey, here's what my Java project is going to be like. You can follow the Maven conventions, so that you say, hey, here's my source code, here's my test code, and as we saw that that Maven it gives you the ability to build all of the source code, run all of your tests, even generate nice reports. We'll learn that there's integration tests in addition to unit tests, all sorts of good stuff there with Maven. So that gives you an automated build. Now, continuous integration takes the automated build a step further and basically says, well, in addition to having an automated build, I want to have an automatic build. And I want to have an automatic build that runs in like a clean room environment. So if, I don't know if you've had the experience, but certainly the experience of lots of software engineers is that you get something to work, it works fine on your machine, and then when someone else tries to do it, it doesn't work. Because there's some environmental dependency, or there's something about something on your local file system that has to be there. And so what continuous integration offers you, again, is that clean room environment where everything starts from scratch. What I'm going to talk about is a continuous integration service that's available in the cloud called Travis CI. Travis is is the name of the tool that builds all of your source code, and CI is for continuous integration. So this is what we'll get back to in a minute. The cool thing about Travis is that it's free. It's on the web. All of the machines that run your continuous integration build will run your automatic build are hosted in the cloud. Nothing that you need to do, and it's tied in really nicely with GitHub. And so what you can do is you can have one of these automatic builds for each one of your repositories. And so I'm going to walk you through in this screencast is how I've configured Travis CI to provide these kind of this automatic automated build for my code. And you get this really cool cycle in that I'm building my application, I commit some code, I push it up to GitHub, and then by pushing it into GitHub, that will then trigger a clean room build of my source code using Travis. So that's pretty cool. So let's see here. The first thing I want to do, though, before we dive too deeply into Travis, is make a couple of changes to my to the source code that we started building on last week. So as you may recall, I created a new GitHub repository. I'll just find that here. Let's see here. There's the classes, and I'll look for the one for that doesn't have. Well, it looks like 2017 hasn't gotten popular yet, so it doesn't show up on the front page. But here's the one that I created last week, and so it's got 3 projects. It's got the airline, the cones, and the student. When I created these, I created each one of these from the archetype, and they're standalone projects. What I want to do, because it'll make it easier for Travis, is I want to basically put all of these Maven projects under a single parent project. So in Maven, there's this concept of your parent POM, your parent object. And it basically is for two things. It's for grouping a bunch of related projects all together, and also it lets them share a common configuration. So if there's a certain piece of configuration, so for instance, you want to say, hey, all of my projects always use the Java 8 language features, you can put that in one place in your parent POM XML and not need to share it among all of the child projects. I use this quite a lot with my projects. As a matter of fact, I think as you'll see, if you look at the pom.xml for mine, they define a parent project here. So when they're created by the archetype creates them with a parent project that I have called CS410J. That's off in the class's group ID, and it's the summer 2017 version of it. And that POM specifies a whole bunch of plugin configuration and information about me as an author and stuff like that. What we're going to do here now is we're going to create a parent POM for all of these projects, just for summer 2017. And what this will allow us to do is to then have a single Travis CI build that will build all of these projects, and then as I add more projects, which I'll start doing in a couple of weeks, adding more projects here, those will automatically get included, again, in this continuous integration build. So a little bit of Maven stuff first before we can really dive into Travis CI. So let's see here. What's the best way to do this? I want to create a new POM file. And I could do that in IntelliJ. Maybe I should do that in IntelliJ. So what I'll do is I will open up, let's see here, I'll just go into the student, and I'll open, is it student.iml? Is that going to work? Nope. I probably just need to go back to IntelliJ and open it directly from there. Oh, there's the stuff from last summer. I think if I have to, let's see here, student. This is, open up in a new window. This is the one, yep, in my summer 2017 repository. Okay, here, and I don't know if I can do this, because I want to create a POM file in the parent directory. Maybe that's not so easy. What if I just did this? I said, I'll just create an empty POM XML file. I wonder if I can open that up in here. And then just open, let's see here, 2017, here it is. POM XML, empty file, open as a file, because I need to edit it first. And does it know that it's a project? Let me just look at another pom.xml, get it started here, copy all that good stuff. Okay, project, and it says project's empty. What does it need? Oops. It's complaining that artifact ID. Okay, this is good. Artifact ID, and let's do some more stuff. I'll get back to you a little later. Okay, so the artifact ID, we're going to call this, this is going to be Portland State Java Summer 2017. So every project, it creates an artifact of some sort. This will just be just a POM artifact. It doesn't create a jar file. It doesn't create any other application type stuff. It'll just be a parent project. It's just that. And so let's see here. I think there's some other stuff that we need, like a group ID, and the group ID will be me. Oh, and it gives it a automatic. So this is my stuff from summer 2017. It's not just the generic stuff for the course. It's like the projects that I create as if I were a student. Artifact ID, and then the version of it, we'll just call that summer 2017. So there's, I guess I could also just call it Portland State Java. Maybe I could do that. I don't think it makes much of a difference. Okay, so it's missing something else. What else doesn't it like? It doesn't like, oh, the model version. Oh, yeah, all this stuff. Now let's just go back to the student here. Model version is 4.0. Okay, that's nice to know. And let's see here, what else? Okay, so it's pretty happy right now. Group, oh yeah, packaging. I think that's an important one. So the packaging in this case, again, it doesn't create a jar file. It creates a POM. And that's that. So that's that project there. I'm just curious, what happens if I just try to say Maven, I just try to say Maven clean, it'll find it. But that's nice. If I say Maven verify, what is it going to do? No, nothing to do there. That's okay because we haven't given it any information. We told it it's a POM, but there's nothing interesting there. Okay, so what we need to do next is say, well, this is the parent, and we need to say what the children are. And so I think you say with modules, yeah. And so then every module corresponds to the name of one of these projects. So let's just start out with airline. So this is saying I have a parent project with one child called airline. So like, what happens if I do a Maven clean now? Aha! It said, okay, I'm going to yep, it's going to build the child project. I'm going to do a clean on that and didn't do a clean on the parent. Okay, nice. Now if I say Maven verify, yep, it's running the, yep, it went and ran all the tests, both the integration tests and the unit tests for the airline project. This is looking pretty good so far. Okay, cool. So now I'm going to add the other couple of modules there. So I'm going to say student and cones. So student and cones. Now let's see what happens when I do a Maven clean verify. I'm doing this from the parent directory, right? So now I'm getting all of this stuff. Maven clean verify. Great, seems to be running everything. And it told me yep, it did all 3 projects and the parent one. So everything looks pretty good. So now what I have is I have one parent project that builds all of the children. And this is good. This is going to be like my, I've got a project of projects, but now when I run continuous integration on it, I'm going to run it on all of these guys. Maybe in the real world you wouldn't do it this way. You might have, actually you probably have something like student and airline and cones in their own GitHub repositories. But I don't want to have a separate GitHub repository for each one of the projects that I create this term. And maybe you don't either. So it's okay to have multiple Maven projects all in the same repository, and as long as they have a common parent, everything should be okay. Okay, is there anything else that I want here? I don't know, I think I might want a name for this project. It's something a little nicer than just that. So it's source code written in class in the summer 2017 offering of advanced programming with Java. Okay, you know what? And I think I want to. No, I'll just leave the artifact ID as that. It doesn't really matter, I don't think. Okay, great. Now that I've got all of this, I am going to, you know what I'm going to do? I am going to close this project. Now I'm going to open up the parent project, the parent POM. Here again, I'm going to open it as a project and not as just a file. So I'm going to open it as a project, open it up in a new window. Let's see, it's reading stuff. It seemed to have worked. Great, so now I have one IntelliJ project that has all 3 of my other projects, my airlines, my cones, my student, all as modules within that IntelliJ project. And that's really nice. And so then and I've got version control, and it says that, hey, pom.xml is not version. This is the parent one. That is correct. I'm going to add this to version control. And I'm going to check it in. So I'm going to say add parent POM for the projects, the Maven projects created during class. I'll commit this and push it. Yeah. Need to restart IntelliJ to fix that. And it's pushing. It's taking a little while, but hey, it's successful. Okay. So now if we go back to GitHub, reload this, and we'll see that now we have this pom.xml. Okay, so now I've got my repository, which basically contains one parent project. And so for Travis, I'm going to configure Travis to have one build for this repository that builds everything from the parent on down. And so here's what I'm going to do. I'm going to go to Travis, And this is like my status. That's probably not where we want to start. I think we want to start with the read our docs. Okay. So Travis has really nice documentation. I'm going to skip around a little bit for the in the interest of getting through this. But if it's something that interests you, and by the way, I probably should have prefaced this. This is not required for the course. This is like one of those things, like the mob programming, like the pair programming, where I think it's something that all uh, it's a part of contemporary software engineering, is having automated and automatic builds. And so I think we'll see some of the benefits of having your code built automatically in a clean room environment as part of after you do every check-in. And it's something that I think you can leverage for your code. I don't know. We should talk about it, but it's something that you should really use. But I think it's something. But it's definitely something I wanted to expose you guys to. So the way Travis works is that in your well, first of all, maybe I should start there. Maybe what I should do is go back to sort of my home here. You tell Travis about the GitHub repositories that you want. So I can add a new one for, let's see here, where is, yep, summer 2017. So I will enable it here. Cool. And now it says, okay, there's no builds for this because, well, I haven't done the things that you need to do to get started. But once I do, then it'll start building. So let me go get all those docs again, open up a separate tab so we can navigate more easily. Okay, where do we need to go to get started? So so Travis is a build system. Or Travis will perform a build on your repository. However, you need to tell Travis how to build your repository. And specifically in our case, we need to tell Travis that the GitHub repository that's being built contains a Maven project that is built with, well, Java, duh, but also Java 8. So there's a little bit of configuration that we need to provide. The way you provide this configuration is in a file called .travis.yaml. YAML is yet another markup language. It's a little it's a markup language that lets you specify hierarchical information pretty nicely. And so you provide one of these things in your repository, and that's what Travis will use to determine what it needs to do to build your project. So well, first of all, I guess we'll go and we'll create here in the top level a new file called .travis.yml. Yes, I want to add it to Git, and I'm just going to always remember that decision. Okay, what do we need first? So let's look at some of this language-specific guides. So Java, always important. So, okay, so the first thing we need to do is we need to say language Java in our Travis YAML. And so that basically tells Travis, hey, when you build this code, you need to have Java available. Now, it defaults to Java 7 by default, so we'll need to change that. And it says later on down here. It also says it'll build with Maven 3.2, which is kind of old by now, but it will get by with it. I think everything ought to work, and we'll see if it doesn't. So we configured the Java environment by saying language Java, and since we want a Maven project, well, since we have a Maven project here, it'll use Maven if it finds a pom.xml. So if in the repository root it has a pom.xml but not a build.gradle. Gradle is another build system, one that's immediately, well, is newer than Maven and has some very nice features, but not what we're using in this course. So if Travis will look at your repository, and by the way, it can do this because your repository is public on GitHub, right? Anybody can check out a public repository on GitHub, including a tool like Travis that sits there and runs in the cloud and does what you tell it to. You don't need to expose any special permissions and stuff like that. So if Travis finds a pom.xml in the repository root, it will run Maven. It'll run Maven Test -b. I don't remember what -b does. But it'll basically run the test phase, right, which will compile your source code and run your unit tests. Oh, it also does a couple of things before it. It first makes sure that it can download all the dependencies, and so it does this install when it skips tests and does some other stuff. And that way, if you're missing a dependency or if there's something that Travis can't see, you find about it earlier instead of like running your build for like 5 minutes before ultimately blowing up. So we don't need to do anything there. And so then, well, let's give it a whirl and see what happens. So I've told Travis, or rather, I said, okay, great. I'm going to configure Travis to run a Java language, oh well, a Java project. And since there's a pom.xml there, it will run Maven. So let's see here. Added a Travis CI configuration file. So I'll commit that and push it. Yeah, super annoying. Okay, pushed it up to GitHub, and so now if we go to GitHub, refresh, sure enough, there's our Travis ML. Now, if we go here, haha, something seems to be happening. It is building, and sometimes it takes a moment for it to build. I won't walk through everything that's going on here in the log, but since I've got you, I'll highlight some of the things as they happen. So Travis is really cool. It runs in well, it has a bunch of, well, I think they're VMs that then run a technology called Docker that allows you to basically spin up an environment, and it's the environment that you want. So I think they have they're like Ubuntu images that that are configured to run the things that you need, like Java. So it'll have the Java tools, it'll have the JDK, it'll have Maven, the kinds of stuff that you need. So here it is. It's checking out my source code there, and it does things like, oh, what version of Java am I running? Okay, it tells you it's 1776. Okay, that probably won't work. It tells you what version of Maven that you're using, 325. Again, it's pretty old. Okay, and so now it's running the build. Now, remember the first time that you ran Maven and it downloaded the entire internet? Well, Travis does this every time. Travis doesn't want to keep a whole bunch of files around in a Maven repository. And here again, it's a clean room environment. So the whole idea is that you start from scratch whenever you build. And this is desirable. Yes, it takes longer. Yes, it's download a whole bunch of other stuff. But it's really important to be able to have confidence that your code can be built and run and compile and can all your tests execute correctly in a completely clean environment. So that way, if someone else starts from scratch, they know that they they can get all the resources they need. Oh, look, it failed. Okay, why did it fail? Okay, here we go. JDK. Oh, and I even got an email from Travis. That was so nice of them, saying that it's errored. So this is cool, right? So I checked in. I mean, let's look what happened here. I checked in a piece of source code. In this case, it was a Travis ML, which kicked off the first build, and the build ran. And it failed, and I got an email about it within seconds of it failing. And this is the whole idea behind continuous integration. You find out immediately when you've done something that doesn't work. So it's that same kind of feedback that you get from like running unit tests or just having the IDE put up warnings and errors in your face when you've done something wrong. You get it from anyway. But continuous integration tools like Travis give you that same sort of rapid feedback. Okay, this isn't entirely unexpected that it failed because I have my Maven projects to require Java version 1.8, and it was using 1.7. So now we need to go figure out how to make that work. I think it's here someplace. Let's see here. I think I got testing against multiple JDKs, maybe building multiple JDKs. Oh, here you go. Okay, there is a JDK key. And you can say Oracle JDK 8. I'm pretty sure that's what I want. So, oops, come on. There we go. Oracle JDK 8. So now we'll commit this. Build with JDK 8. I'll build on Travis with under Travis CI. with the Travis CI, build with JDK8. Okay. Push that up. Takes a moment to push. I wonder why that's slow. Okay. So we have that documentation here. We'll go back here. A new build has started. Build number 2 has started. And then we'll watch it and see if it goes any faster. While this is all going on, there's some other things that we can explore. So like build history will tell you, well, the history of your builds. You can go back and look at the results, especially when things have been failing for a long time and you want to see when it started failing. This will help you there. One of the cool things that Travis will do is that it will do a build when you make a pull request. So a pull request in GitHub is a way of having one contributor say, "Hey, well, okay." So there's something in GitHub called forking a repository, where basically there's a repository, and a fork is like your very own copy of that repository. And so then, hey, let's say there's some open source project out there. And I want to make a contribution to it. I'm not one of the authors per se. But what I can do is I can make a fork of their repository, make some local changes, changes in my repository that maybe implement a feature that I want, and then if I want to contribute those changes back to the primary project, I can do so by making what's called a pull request. So, like you see me do a git push to push code from one repository to another. A pull is to say, hey, pull code from one project to another. And GitHub has some really nice workflows for reviewing the code and providing comments on it and things like that. Anyway, so if I were to make one of those pull requests, Travis, who has access to the GitHub repository, can go and notice that a pull request has been made and can essentially try to merge that code in, like do a pretend pull, a pull but not, I guess, move it all the way up to the full repository. And make sure everything builds, make sure all the tests run. And so this is really cool, right? This gives you a lot of confidence that, yes, hey, this is a good set of changes if all the build tests, all the code still builds and runs once the, or rather will build and run once the changes have been in here. Okay, hey, looks like we had build success on one thing. So actually, what was it? So why is it building it again? I wonder if that was just the build that got all the dependencies. It might have been. So that went through and made sure all the dependencies were all cool, and now it's going through and running the unit tests. It's running that Maven-B tests. Aha! Okay, and it looks like we're successful. So we should see a green build up here. Oops. Let's scroll to the end of log. Now I want to go back up to the top. Yay! Okay, everything has passed. So that's super cool. And I think I should be getting an email here any moment saying, "Hey, your build passed." And that's really nice. What's the config here? Oh, there's the config. That came from, there it is. Yep, the build passed. Happy green and everything. I can still link to it. Oh, and it also tells me, also lets me link off to the set of changes that were included in it. So anyway, it's really nice. It's really cool, and it gives you some pretty slick feedback. I think there's one more thing that I want to do. I've got a passing build right here, and that's pretty nice. However, if I look at the Maven commands that it did, let's see here. Where's Maven? Okay, so it goes and this is the Maven install where you don't run the tests and where you skip the Java docs. That's cool, and you can expand it here. As you can see, it's like 1,300 lines of log output that will get collapsed. So that's cool. So it says here's the top level command that was run. And this is like the install phase or something, and it ran for 93 seconds. That's kind of neat. And then it just runs the tests. That's kind of interesting. Some problems will occur about building the effective model. Blah blah blah. Okay, maybe we'll fix that at another time. Because there's one other thing that I wanted to do. So that's Maven Test. Now, Maven Tests only runs the unit test, but I've got a bunch of integration tests with mine. So I want to change the Travis to, instead of running just Maven Test, to run Maven Verify. What's that Maven dash B thing? What's Maven dash B? What does that mean? Dash B. Oh, this isn't. That's not the Maven command line. I'll just do the Maven-H here, I guess. So Maven-H. I have a personal pet peeve whenever, especially in scripts, whenever I have a command line option that has a dash, I always use the long name so that I don't have to remember what it is. I mean, how do I know that's batch mode? Right, and that's nice. Okay, so it runs in non-interactive mode and also disables colored output. That's pretty cool. Why didn't you just say dash batch mode? You know, it's like we're not, gone are the days where we're going to run off the end of the punch card if we have too many characters on the line. Anyway, just a little pet peeve of mine, and something that I like to do. Okay, so I'll remember that batch mode, because what I'm going to do now is I'm going to specify my own command line for Maven, which I wonder if it's on this page. Examples. Oh, that's something else. Oh, maybe script. I think that's how I might do it. JDK language installed. Gradle. Oh, let's see here. Customizing my build. Build lifecycle. Okay, yeah, there are all sorts of things. Okay, there's the install, and then there's the run the script. So we'll still have the same install. That's fine. But now our script, we're going to have the script be. Oops, I don't want all that indentation. Oh, I'm so glad you think that you're smart. Okay, good. And now I want the script to be Maven --batch mode verify. So instead of, let me make sure I got that right. Instead of test dash B for the script, probably doesn't say script there. Or yes, instead of that, it's going to be this. That sounds good. Okay, give that a try. So with Travis CI, run the verify Maven phase instead of just test, so that the artifacts are built and the integration tests are run. Push that up. Okay, we got yet another job. We'll watch that go by. Really won't watch it go by. I should edit that out or something. It's probably like super boring. Luckily, it only takes a couple of minutes. So I guess as I was saying, there are a number of reasons that you want to that continuous integration provides benefits. And one of the ones that we'll see in class on Wednesday is that now, as I'm doing my test-driven development and as I'm pushing changes up to the up to GitHub, Travis will then be working in the background to then verify that yes, all the changes that I've made, the tests that I've added, the refactoring that I've made, make sure that everything still builds and that all of the tests still run. And this is really powerful. This is, this gives everybody confidence, both the author of the code and then anybody else who's working on the project, that the state of the code, the state of the project is well known, and that it's functional, right? You've got all these automated tests happening because as you build up your applications, you build up your code, more and more tests are being added, more and more code is being written, but yet you've still got that same level of confidence that everything is running as it should. and it's not dependent on just one developer's local environment being set up correctly. That the entire environment is able to be reproduced independently of any given machine, and that all of the code will build and run successfully in that clean environment. Okay, that looks pretty good so far. Was that the end of it? I wasn't paying attention as I was pontificating about the. Oh no, looks like okay. There we go. Okay, batch mode verify. Now it's doing the real work. Sorry, let's follow the log. So there's running my. Okay, it ran the unit test really quickly. It ran the integration test. Good. And now everything seems to be happening. It's a nice quick build. It's nice when the projects are this new and and they run really quickly. As we go on in the course, as we add more projects, as the projects do more things, your builds will take longer and longer, and that's okay because they're doing more stuff. Now, at some point, a build that takes 6 hours isn't very useful. You won't because the feedback takes too long. But getting feedback within like 10 minutes of making a change, that's really, really valuable. So once again, we have a passing build. So, I think this is where I wanted to go with today's screencast. As we've seen, we've used a tool called Travis CI to set up what's called a continuous integration environment for our GitHub repository. And we modified our GitHub repository to have a parent project that builds all of the children projects. And what this allows us to do is every time we make a change to that repository, to any of those projects there, a new build will be triggered, and it will verify that that yes, all the code can be built, and that all of the unit tests and all the integration tests, basically all that stuff that Maven Verify does, all works correctly. So, thanks for listening. Happy Independence Day, everybody, and I will see you tomorrow evening in class. Bye now.